Alrighty, so this is the geolocational radiation detector. And what it does is it takes a GPS reading as well as a Geiger counter reading at a point wherever I am. So the GPS tells us where we are in the world, and the Geiger counter tells us how much ionizing radiation is around. So under the hood here, we have the Arduino tucked back in there, as well as our breadboard here. You can't really see it, but I'll show you a schematic in just a moment. The Geiger counter is connected via an audio jack, and that gives a pulse every, randomly, whenever ionizing radiation comes in through this window and strikes the Geiger tube inside. So one of the biggest parts of the data acquisition here is that the radiation comes randomly, so you never know when it's going to come, and when it comes it's a very, very short pulse. And the way we combat that is by creating a voltage divider inside, and that will give us an analog value that kind of stays up above the threshold for just a little while longer than the pulse would be there. We're powering the thing with this 12,000 rather milliamp hour battery. That's real nice. Lasts for a couple of days. And the GPS here is hooked up to the breadboard as well as to the Arduino through various pins. So now as well we have an SD card reader on the inside here. And now we go ahead and take a look at our circuit. So we have the Arduino Uno. On the analog input we have, and headed to the voltage divider, of course it is measuring the voltage referenced to ground, and the Geiger counter just sends a pulse whenever into there. Because the Geiger counter is hooked up to a 9-volt battery, it sends, well, upwards of 9-volt pulses. So I was having an issue with it saturating the analog inputs. I just had to put in the right resistor values, and we got some nice values for the analog input there. Now over here we have the GPS, and that is hooked up. We have the enable pin, which is hooked up to 5 volts. Basically it tells it to listen when it's high. And then we also have the voltage source hooked up to the 5 volts. Now the RX and the TX pin, which are the receive and transmit pins, are connected to the Arduino's D3 and D4. These are basically what the Arduino uses to talk to the GPS, and the GPS uses to talk to the Arduino. As well, we have the ground pin headed to ground. Now over here we have the SD card, and that's just hooked up through the 4 typical pins that are used for every project there, so I won't go into detail with it. So now what about the data? Well, here it is. We have our map. This is Cal Poly, and in fact if we zoom in here, we have, this is Baker, and this is H-bar, as you can see by the million points that are there. And if we click on a point, we can see we had 7.2 events, and the N is the number of times this particular latitude and longitude popped up. Let me see if we can find one with, you see N25. That means this particular latitude and longitude popped up 25 times, and the radiation was 2.4. Now, if we zoom out a little bit here, we see up here we have my apartment in Poly Canyon Village. It actually has some quite high levels of radiation. That's pretty impressive to me. I'm not sure what that corresponds to, if it's just an error or if that is actually an area of high radiation. So that might be something to look into in further data collection. You see we got a 0.4 there, that's a pretty typical point. Now these are scattered a little bit, and I believe that's because in my apartment there's not a particularly good view of the sky, so we don't really get a good GPS reading. It kind of hops around. So there's that. Now, as you'll notice, the points are colored. As you can see over here, we have a color scale from red being the lowest to blue being the highest. You see we got some very colorful points over here, and then if we head back to H bar, we have, you know, not as colored, but you know, they're pretty okay. Those, you know, correspond to those kind of on the order of magnitude of 1, or you know, 1 to 10 over here, and you've got 7.2. So that's what the data looks like. Writing in the SD card kind of posed an issue. We had points pop up that were not, well, you know, I wasn't in the middle of the Pacific Ocean there. I've also haven't been to Africa, and haven't been to the Gulf of Guinea. But these points correspond to errors in writing to the SD card. Things like our latitude is something like 35.3 blah blah blah. Well, sometimes the 35 would be truncated, and so we just get a 0.3, and so that kind of, I think that's the point in the Pacific Ocean over there. So we get some pretty nice data, and we're able to look at it and tell, you know, where the radiation is and how much is there. So I would say that's a fairly nice representation. As well, this can be expanded further. We can make it smaller and a little more compact and map out more radiation with a better GPS. So that's my project there, and thank you very much.